We will be exploring the lab, How is the Heat of Combustion Measured Indirectly, with Natalie, Dion, Caitlin Loeza, Taylor Parker, and Irene Reyes.
This is Taylor Parker speaking for the introduction section of this presentation. So, as you see on the lab, I have 3 important concepts, and I'm going to try to verbally explain the interrelatedness between all 3 of them. So, as a reminder, the purpose of the lab is to discover the total enthalpy of the equation displayed. So, if you note the actual equation, you'll see that there are different reactant states, and at the end we end up with a solid. So, to account for that change in state, we're going to have to use Hess's law, as it's going to be that multiple steps of that reaction, and again it's the sum of all changes, and our purpose was to find the total. So when you use Hess's law, you're going to have to be dealing with delta H, the sum of the products and minus the sum of the reactants, and delta H just refers to the heat in that system. And you'll see in chemistry, heat is often referred to as energy. And that's how the energy is transferred and changed from one form, because again, it's going to be that change in state. So that's how all 3 of these concepts come into play.
Hi, I'm Caitlin Loeza. I'm going to be talking about the materials and methods that were used to perform this experiment. The materials that were used in this experiment included hydrochloric acid, magnesium ribbon, magnesium oxide, a colorimeter, which was basically a styrofoam cup, a temperature probe, a scale, and lastly, a 50 ml graduate cylinder. The experiment was performed by conducting 2 reactions, one which included hydrochloric acid and magnesium oxide, and the second reaction which included hydrochloric acid and magnesium ribbon. To start off the first reaction, the colorimeter was zeroed out onto the scale, and 50 ml of the hydrochloric acid was then measured into a graduated cylinder and poured into the colorimeter. Then 1 gram of magnesium oxide was weighted on the scale. The initial temperature of the hydrochloric acid in the colorimeter was taken, and then when the magnesium oxide was added into the hydrochloric acid, the highest temperature reached was recorded. Basically, everything that occurred in the first reaction occurred in the second reaction, such as hydrochloric acid being measured out and its initial temperature being taken. But the only difference with the first reaction is that in the second reaction, 3.5 centimeters of the magnesium ribbon was measured out and added into the hydrochloric acid, and as well the highest temperature was recorded. And then after the both reactions were performed, Hess's law was then able to be calculated.
This is Natalie Dion with the results section, and the purpose of the experiment was to find the delta H for the reaction of interest by finding the delta H for reactions 1 and 2 and using the given delta H value for the third reaction. For reaction 1, the heat was calculated using Q equals mc delta T, and the initial mass of hydrochloric acid, initial mass of magnesium, initial temperature, and final temperature values recorded from the experiment. This value of 1827.4 was in joules, so it was divided by 1000 to get 1.827 kilojoules. Then, the moles of magnesium were calculated by dividing the initial mass in grams by the molar mass of magnesium, which yielded 0.00284 moles of magnesium. Finally, the heat was divided by the number of moles to find delta H, which was 643.31 kilojoules per mole. For reaction 2, the heat was also calculated using Q equals mc delta T and the initial mass of hydrochloric acid, initial mass of magnesium oxide, initial temperature, and final temperature values recorded from the experiment. This value of 699.2 was in joules, so it was divided by 1000 to get 0.699 kilojoules. Then, the moles of magnesium oxide were calculated by dividing the initial mass in grams by the molar mass of magnesium oxide to yield 0.00521 moles. Finally, the heat was divided by the number of moles to find delta H, which was 134.17 kilojoules per mole. The delta H of reactions 1 and 2 become negative because heat from the system was lost to the surroundings, but reaction 2 is flipped to get the reaction of interest, making it positive. Everything that cancels out from both sides was removed, and you are left with the reaction of interest. Then, the three delta H values are combined to find the final delta H for the reaction of interest, which was 794.94 kilojoules per mole. Finally, percent error was calculated by subtracting the experimental value from the theoretical value, dividing by the theoretical value, and multiplying by 100, which gave us a percent error of 32.1%.
Okay, so my name is Irene Reyes. So, as it was told before, the main goal of this experiment was to determine delta H, specifically using Hess's law, which was magnesium solid plus 1/2 of oxygen 2 gas into magnesium oxygen solid. So in detail, Hess's law mentions that the total enthalpy, meaning delta H, is the change of a reaction, is the sum of all changes. So the hardest part of this experiment is trying to perform the reaction because of the O2 gas. So in order to calculate delta H, the equation Q equals mc delta T was used. And as it was explained in the results section, the rest of those steps and calculations were done, and then the percent error was then able to be calculated.
It's Caitlin Laws again. Some of the potential errors that occurred in this lab included the loss of heat due to the fact that no styrofoam cover was used to cover the styrofoam cup. This led to the experimental enthalpy to be calculated incorrectly or inaccurately. A way that this problem could have been avoided was simply to have used a styrofoam cover to prevent the heat loss. Another potential error that could have occurred could have been that some of the magnesium oxide was left on the weigh boat and wasn't fully poured onto the colorimeter with the hydrochloric acid, which could have led to inaccurate data of the final temperature. To have prevented this problem, one could have made sure that the magnesium oxide was fully poured onto the colorimeter by scraping off any of the magnesium oxide left on the wave boat with a spatula. So overall, this investigation was a success since the change of heat was able to be calculated using Hess's law.